Hello, and thanks for joining me today. My name is Yotam Ben Ezra. I run product management for data and AI security within Cortex Cloud in Palo Alto Networks. What I'd like to talk about today is share with you some learnings from research done in Palo Alto regarding new threats in the AI ecosystem. I'll talk about those and share a little bit of a few examples, 3 examples of how these threats can be manifested in attack scenarios. And we'll talk through the key findings in each of those categories. Following that, we'll share a little bit on how Palo Alto addresses AI security within Cortex Cloud as well. So let's get to it. So we know that within a few years, every application will be infused with AI. Organizations are getting a lot of ROI by introducing AI functions into any type of application which is running in the organization. And the growth and pace of adoption of AI in organizations is simply huge. What it means that enterprises we talk to today are introducing AI into multiple layers of their applications and multiple layers of their business. What it means for the security team, or what it looks like for the security team, is that there are different teams across the business, and each of them are creating new initiatives involved with adopting AI and building AI into their applications. So a typical enterprise and a security team will have the support team building a support chatbot to help customers, the marketing team building a data analytics AI-driven capability to analyze data. Different product teams are building AI into their product capabilities. And then IT internal teams creating additional AI capabilities for either productivity purposes or for reducing caseload purposes or multiple use cases. The outcome is that a typical organization will have anywhere from tens to hundreds of AI initiatives going on at any single moment. Some of them will be more advanced than others from an adoption perspective or a production perspective. But this is something which is very hard to control. And so for a typical security team, the key questions that are being asked in terms of how to secure that ecosystem starts with what is being used in our organization, what LLMs are used, what type of AI models are deployed, how can we prevent the exposure of our assets, whether it's our crown jewels or data assets, which are introduced as part of the AI application, and how can we, of course, secure those prioritized issues across our AI ecosystem to reduce the resulting application risk. Now, if we think about how this risk or attack surface is built, then, of course, everything starts with the modern enterprise environment, which today is composed of multiple layers of infrastructure, whether it's cloud, data assets that is exploding, applications, identities, endpoint, and network. All of those are parts of the, I'd say, traditional enterprise or modern enterprise ecosystem. On top of that, when we introduce AI into the application, there is a set of infrastructure that is being introduced, whether those are prompts, models, training data, retrieval augmented generation associated data, AI agents, MCP servers. There is a bunch of artifacts which are introduced on top of that enterprise environment as part of the AI ecosystem. And there are the associated AI risks and threats, whether it's prompt injection, data poisoning, module hijacking, wallet abuse, jailbreak. There are additional specific AI risks and threats which are associated with this new AI ecosystem. And so let's discuss a little bit the main categories of threats which are proliferating across the AI ecosystem and threat landscape. And there are 3 that we are going to focus on today. Of course, it's not comprehensive coverage of all the AI threats out there. There are, of course, also the traditional threats. As AI is introduced as part of the infrastructure in enterprise, and AI will be part of the applications, there are all the existing layers of threats which are associated with an application, whether it's data, whether it's identity, configuration, vulnerabilities, workloads. and essentially all the different layers of traditional threats. The session today is focused on the AI-specific threats, which are three categories that we've identified are key to essentially understanding AI attack vectors. And we'll talk about each of these categories and also look at a quick example and key learnings for each of those. So the first one is, of course, malicious models. In many cases, models are coming from open source repositories. And in this case, one of the things that is very important to control is what's inside the model and how do we control the fact that the models that are actually being introduced into our environment are not malicious and will not do unexpected activities in our environment. The second is prompt attack. Prompt attacks, a huge attack surface, very known, and we'll try to break it down and sort of talk about what it means and what are the different aspects of prompt attacks which exist. And finally, agentic applications. As agents are introduced more into the environment and being given permissions to perform actions in the environment, it is super important to think about what an unexpected behavior from an agent might generate or might cause, what damages it might cause, and how do we scope agent activities to something that we can adopt securely and quickly. So let's get to it. First scenario is deployment of malicious modules. Let's go over this example. It's just an example. There could be other examples of how this could be done, but think about a public repository, something like Hugging Face or any other. And our development team finds capabilities which are advertised as part of the model as something which is interesting to explore. That model is downloaded into the environment and is run, whether it's on a managed service or a self-managed compute. And then essentially, once it's deployed, there could be many things that might happen. First of all, it might escalate privileges, it might create data exfiltration, it might execute unauthorized actions. One of the things that our research found is that in some cases, because of the way that models are deployed and because of potential vulnerabilities in the infrastructure itself, and because of the way that training jobs are being performed, specifically in Vertex in this case, but there were abilities to essentially extend and elevate privileges for a model which is running as part of a training job or as part of the Vertex infrastructure. And in this case, essentially, it would generate access to all of the other models in the infrastructure and essentially extend the potential damage of that model deployed. So what do we learn from this? Of course, this is a specific example of a specific vulnerability and a specific scenario. The paper does describe in more detail, and it's referred to here and describes in more detail various aspects of this vulnerability and the different stages within this potential attack. But of course, we cannot assume that we are familiar with all the vulnerabilities which might exist in CSP infrastructure or in self-managed infrastructure. Hence, the way we should treat it is that a single malicious module could compromise a wider range within the AI environment or the entire AI environment. And we should essentially sanitize the models that are running and sanction which models are allowed to run in the environment. In this case, what happened was that seemingly harmless permissions, as I mentioned, typically as part of a model running in the environment, there is a limited set of permissions. In this case, the vulnerability meant that those permissions were elevated to grant access to critical parts of the environment. So essentially, malicious models not only can run in the scope that they are given, in some cases where there are vulnerable infrastructure, that could create horrendous results for the environment. So let's keep that in mind. And I think the key conclusion from this is that we have to have visibility into what's running in our environment and be able to understand what is allowed versus what is not allowed, and be suspicious with models coming from unknown sources. Category number 2 is prompt attacks. Well, prompt attacks is a big word for essentially a set of techniques which are interacting directly with the model prompt and can achieve various outcomes. The paper by Unit 42 Research essentially divided the different types of prompt attacks to try to essentially provide a taxonomy and a categorization of what could be the potential impact, what could be the method, or what could be the specific technique used in each of these attacks. So from an impact perspective, it could be a guardrail bypass. So models typically run with guardrails, and prompt attack techniques could be used in order to cause the model to behave or to essentially provide outputs which are outside of the guardrails allowed. The second impact is information leakage. So prompt attack techniques could be used in order to reach sensitive information or to leak information that was not intended. Third one is goal hijacking, which means causing the model to behave in a way which was unintended. And of course, there could be attacks on the infrastructure itself, corrupting either infrastructure or the AI infrastructure itself. From a techniques perspective, there were several techniques identified, whether it's the prompt engineering, social engineering, obfuscation of messages, knowledge poisoning. This is just the categories. There is a detailed description in the paper regarding each of those techniques and how they may be manifested in prompts. One of the things that is important to understand is that the attack surface for prompt attacks is very, very wide. The reason it's super wide is because essentially we are transmitting free text into a model. Now, if you're familiar with SQL injection, for example, this is a formatted language, and the variety of attacks in that formatted language is super high. With the degrees of freedom that free text and model interpretation provides, the variety in techniques is something that is essentially vast and will grow significantly. So there is a set of known techniques which was identified today, but one of the predictions is that the variety of potential attacks is so big that we're going to see this grow from attackers. And it is key to make sure that security tools we are using in order to essentially monitor and protect from those types of prompt attack techniques are up to date with the new techniques which we expect to be coming out all the time. Because it's a free text interface which is being interpreted by something which is black boxish in its nature. So the third category is agentic applications. So let's look at a scenario here. In this scenario, we have a model which is using a tool. Now, in this case, the model or the agent is not scoped to or well enough into which tools they are supposed to use. And so the attacker creates a tool and essentially then instructs the model, the AI agent, to invoke that tool. That tool will have an SQL injection payload, and that will target a protected database in order to leak sensitive financial information. So the first thing we are learning from this scenario, and of course there are multiple scenarios around agentic applications. This is an example, and of course in the paper you'll find many other examples. But what we learned from this scenario is that we don't always need prompt injection in the case of an agentic application in order to trigger an attack. In this case, this was poor scoping of the model, the agent. Of course, prompt injection is one of the most potent, versatile, and prolific attacks out there. So we should protect agentic applications from prompt injection as well. We should be aware of which tools are used by each agent and make sure that we provide for each agent the right agency or the expected agency. There could be misconfigured or vulnerable tools out there, and if agents are directed to use them, of course, it's an issue. Of course, credential leakage is a major issue in cloud environments and will also be a major issue with agents. One of the key points here is that the impact of credential leakage or the access to the agent could be extended by the permissions that the agent itself is allowed to use. So one of the things that is important to note is that with agents, scoping is one of the most important aspects of how we treat it. Because there are so many options to attack agentic applications because of different stages, the different tools that are used. One of the key findings of this research was that no single mitigation is sufficient. We cannot put a perimeter in one place, like inspecting the prompt, and expect that that will solve all our problems. We need to think about a wider approach to how we protect agentic applications, which would typically be multi-layered. So what does that mean, multi-layered security approach to AI security? It starts with prevention. Of course, we need to make sure that AI security posture is managed properly and that we are able to reduce risk to our AI environment and reduce the AI attack surface. So, of course, enforcing least privilege is an example, identifying misconfigurations across models, data, and the different tools, validating where models are coming from, and being able to harden the configurations across the environment. That, of course, starts with visibility, having the ability to view all of the models running in the environment and all of the associated pipelines, understanding those relationships, and finally, essentially reducing risk and limiting scope. We then need to apply protection. Applying guardrails and input validation, both on the CSP front, on the configuration front, but also there are several security tools we provide that. So monitoring prompt traffic to block malicious activity and enforcing controls to both on the inbound and the outbound of an AI application, such that we're able to control the runtime part of it, because we are not going to reduce the attack surface to zero. Or at least that should be our assumption. Finally, detection and response. So first of all, we want to monitor all of the prompt activity and identify malicious behaviors, signs of exfiltration, suspicious activities, suspicious geographical access patterns, suspicious time access patterns, and essentially identify threats which have bypass the previous two layers early in the chain, and once we've identified those, we want to be able to respond, and we want to be able to do that at scale. The reason we want to be able to do it at scale is that the attacker side is essentially also applying AI and automation into attacker techniques. What this means is that it's much cheaper to attack or to create an attack attempt. And so what we see is an increase in attempts for attacks as a result of this. And in order to essentially address that increase, we have to be able to respond at scale. And the only way we're going to be able to respond at scale is utilizing automation and smart remediation activities. So we want to automate policy enforcement across the modern enterprise. So whether it's at the code level, at the cloud level, all the way to runtime and the workloads. So how does Cortex Cloud address that? So first of all, across the enterprise infrastructure, a single AI security platform which protects both identity and data and the AI infrastructure across the modern enterprise ecosystem. One of the advantages of this is that it enables a single repository which allows us to not only understand which models are running in our environment, but also to understand the different relationships those models have to the other parts of the application, whether it's the data that is used in training or RAG processes, whether it's the infrastructure, the workloads themselves, the managed services, the identities which are entitled to use those, and how those are used. Of course, we can then apply a uniform risk and compliance framework to that infrastructure. So whether it's misconfiguration, supply chain attacks, data exposure, we want to be able to contextualize those with one another and essentially see them all in one place. Of course, we can utilize existing AI frameworks in order to ensure our attack surface is managed well. Some organizations use NIST AI, OWASP Top 10, and others. And of course, in the same platform, detection and response, which is contextualized with the visibility into the infrastructure and the associated data sensitivity. So looking at prompt injection, data poisoning, unauthorized AI models running in the environment, and access patterns to those will help us detect threats in runtime and early, and respond to them in an automated way. As part of the Cortex Cloud platform, we have the best-in-class AI security posture management. It includes three main capabilities. The first one is the ability to map the AI pipeline and understand how the different components of the AI ecosystem are linked to one another. So we have our models, we have the API endpoints associated with those models, we have agents, we have inference and training data sets. And one of the key points is to understand how those are related in order to understand how they're used in our applications. And then also to control what is running in our environment. The second important part of it is the ability to monitor how sensitive data is impacted as a result. So here is where we utilize our in-platform DSPM capability, which already scans all of our data sets. In this case, we identify which data sets are associated with our AI ecosystem, and it allows us to essentially prioritize sensitive data exposure, data poisoning risk, privacy issues, or security breaches as a result of the AI application ecosystem. Now, not only it allows us to do that, it also allows us to prioritize which other AI risks that are identified in the environment we want to address first. Because obviously most organizations would want to address sensitive data associated risk before ones which is not related to sensitive data. So across supply chain, misconfiguration, missing guardrails, and other AI risks, the ability to see them in the context of the sensitivity they represent is key to our remediation. And of course, it includes compliance monitoring for the top AI association standards, including NIST and OWASP Top 10 for LLM as well. So we're able to utilize the platform to automatically monitor where we are with regards to those compliance frameworks. So with that, we'll finish today. I want to thank you for your time and your attention. Of course, I invite you to dig deeper into the papers that I mentioned today. All of those are available in our website. And of course, I invite you to see AI-SPM in action and request a live demo today utilizing either this QR code or the link which is here in the bottom of the slide. You can get a personalized session with an AI-SPM expert. You can understand how it fits into your environment and what's running in your environment, and to kickstart your evaluation of AI-SPM. So I'll thank you with that, and hopefully see you on the next webinar. All the best.